What's going on, everybody? It's Wednesday. It is 4 o'clock, and live from the road, this is Streaming on Streaming. Welcome back, and welcome again to Streaming on Streaming, the live show on the AWS Twitch channel that is all about building live streaming applications with a developer focus and specifically a focus on Amazon Interactive Video Service. As I said briefly before the intro video, I am on the road today. I am broadcasting live from the greater Atlanta area where I am on the road attending a conference and speaking about Amazon IVS. I'm really excited about today's episode here on Twitch. Joining us today is one of the senior engineers on the player team, and we're going to talk all about the player SDK today. So the format's going to be a little different today. We are going to talk about the player SDK with John, and then in the second half hour, we're going to actually get into the IDE, start writing some code, and show you how everything works. So if you remember last week, when we started looking at how to create channels and how to get started broadcasting to a channel with Amazon IVS, today we're going to take it that next step and look at the Player SDK and see how we can start creating playback experiences, see the various methods, event listeners, all this kind of good stuff available with the Player SDK. So without further ado, let's bring on John Bartos. Let me unmute you, John. And of course, we've got some technical difficulties.
I think we're here.
Okay, yeah?
Yep, we're good.
Cool, excellent.
Hey, Todd.
Hey, welcome, John. Good to have you
Thank you.
here on the stream. I'm just checking OBS to make sure everything looks good. Everything does look good, so welcome. John, you are, as I said, a senior engineer on the video clients team here at Twitch. You've been here since 2019, is that right?
Yeah, September 2019. Kind of just like had a few nice months before the pandemic. Got some good food from the Twitch office, got to visit a few times, and then right into lockdown. But I actually started remote. I'm based out of Brooklyn, and I wanted to stay here because, I like it here a lot. So, yeah.
How long have you lived out in Brooklyn?
I'm from New Jersey, but I've been in New York for 7 years now. So I've kind of been stuck here, and I love it. So San Francisco is beautiful, but this is home. The food is very tempting, though, I will say.
In San Francisco?
In the cafeteria, the Twitch cafeteria.
Yes. The Twitch. I got to experience that a few weeks ago when we were out at Demuxed. Was just kind of blown away with the amazing quality. And I've already got, I think, housekeeping knocking on my door here, but we're going to go ahead and ignore that. I don't know why that's happening. But so the food at the cafeteria is amazing. And it's a cool place. It's a really cool office. I mean, I know it's kind of, the Silicon Valley kind of, you've got your, neon signs and your gaming chairs with the Twitch logo, which actually I still would love to put it out to the organization. I would love one of those. I will pay for it no matter what. I need to get one of those purple Twitch gaming chairs. But so you've been here since 2019. You were before that with JW Player, is that correct?
Yeah. I started my career in streaming at JW Player. I think that was my second job, and I really wanted to work in live streaming. I actually really wanted to work for Twitch for a long time, and at the time I was still like breaking into the industry, and I got a job at JW, and I was like, oh, the player team. What's a video player do? That doesn't sound that hard. And I spent 3 years there where I did pretty much everything on the video player at some point. And then during my tenure there, I also started working on HLSJS, which is a big open source project. We were using it internally, and we started using it so much and kicking back features and bug reports and whatever, got permission to just work on it kind of as my job. And from there, kind of the rest is history. I really wanted to be in the live streaming space more firmly.
Is it
which it is?
Well, yeah. Was it? Well, I mean, It's the pinnacle, right? You can't get any higher in
Yeah.
the streaming world than Twitch for sure. What is it specifically about? Is it just kind of something you fell into, or what is it specifically about players and HLS and video playback that interests you, or is it just the fact that it's in that kind of universe of live streaming and that you're kind of connected to it?
Yeah, that's a great question. And it's a little bit of all of those things. I know I wanted to do JavaScript. I really like the web. I love the web as a platform. To me, it's like the most fun and compelling thing that I wanted to work on. My degree is in electrical engineering. So
Oh wow!
I've gone pretty deep and I kind of decided, yeah, I don't really want to do embedded or too low level, but I was really attracted to like the deep problems in live streaming. It's not a solved problem. There's no definition of correct for a lot of it, and it's really interesting, like the amount of challenges we have just trying to get live video at 8 megabits a second in under a second to anywhere in the world, and trying to make that play well on anyone's device. So I was really attracted to that, and also I love Twitch. I love streaming. I've been on Twitch since February 2011.
Wow!
Yeah, and I've been watching pretty much daily since then. Yeah, it's been kind of a long time. So I'm a big
Seriously.
fan of just live streaming in general. Yeah, so to work here, it's been a big career goal for me, and yeah, it's turned out to be just as challenging as I thought it would be.
Right.
Uh, yeah.
What do you stream? Do you game or
Oh,
gamer? Or?
I don't stream
No, you
myself.
don't
This is
stream. Okay.
actually like this is like my second time on Twitch, I think. The first time, I think I just opened my phone and I pointed it and I'm like, "Look, I'm on Twitch." But this is my first time actually on a stream. But I just watch kind of whatever. I have some people I've been following for a long time, some new faces, you know, I don't play Dota anymore. I played way too much Dota, but I still like watching the international, which just wrapped up.
Right, right. You said I'm already going off track here, but I'm kind of interested in this one. You said your degree's in electrical engineering.
Yeah, yeah, electrical and computer, and a lot of people see that on a resume and they're like, "Yeah, this guy can program," but I did like assembly. It's like I
Right.
didn't know anything about JavaScript, and yeah, I kind of just I taught myself it with a coworker at my first job. But yeah, I was not a good programmer in school at all.
So, like, can you like if you had a whatever a monitor or uh, an Xbox controller go bad, could you open it up and like check out
I
find
guess it's
troubleshoot
so far
it?
from my I get so far from my degree. It's more like I learned about how electricity works,
Right, right,
and
right.
in terms of this is how a diode makes voltage change or something. And then the degree was kind of starting from that all the way to here's how you make a computer in assembly. Here's
Right.
all the pieces. So I know how computers work pretty well, but yeah, in terms of web, when I came out of school, I knew nothing about that at all.
I have a odd hobby of, and I think I've mentioned this on the stream before, but I have a very strange fascination with watching a lot of electrical engineering streamers and
Oh, really?
videos. Yeah. Have you ever heard of Big Clive?
No, but I'm gonna write that down.
Yeah, Big Clive. He's Scottish and he lives in the Isle of Man, and he posts a new video like every day. And for being an old guy that I am and kind of out of touch with the rest of the world, this is the first person I'm actually a patron of on Patreon. So I actually like
Oh,
I
wow.
enjoy his stuff so much. He's got an amazing voice. I mean, once you watch one of his videos, it's just that Scottish like, and he's funny and but
Yeah.
he tears things down, reverse engineers them, fixes stuff sometimes, does little projects. I'll watch this guy for hours, like every single night before I go to bed. I'm tuning in. So I have this weird fascination with electrical engineering. I have such a little understanding of it, though.
Yeah.
Even after watching him for like almost 4 years now, like religiously, I can I kind of get. I know what a capacitor does. I know what a resistor does, a diode, and all of this stuff. But I don't know. It's just kind of been my little hobby. So 6 years, right? 6 years that you've been working on
I
video
think like
players.
2016 is when I started, May 2016. So yeah, we're it's going on 7 this year, actually.
Right.
Yeah, and I've been surprised that I can still find things on players to work on.
Well,
So every
and
time I think like I've done
exactly.
it all, there's more to do.
What is it? What is it that are you? Did you kind of picture yourself sticking with one area of focus, or it's just kind of
Yeah,
how it's
I
happened?
I actually didn't. I plan on going up the stack
Yeah.
and up the video stack and trying to round out my knowledge of like transcode and delivery and ingest and start to build more of a picture of like what it's like to work on an end-to-end video system and the challenges there. Um, but I've kind of gone up the stack in a different way, and I'm more interested these days in uh, figuring out how to better ship players and how to better test players, because that's one of the hardest things that we do at Twitch is releasing a new version of the player almost about every 2 weeks to the web platform, which is my forte, or the my squad that I work on. And how do we do that in a way that doesn't break or doesn't introduce more buffering or latency, especially considering the amount of devices and different environments
Right.
that a player runs on. It's like truly incredibly difficult to test when you get to a certain level of complexity. So that's my current fascination. It's like, how do we test better? How do we release better? How do we all work together on this big code base together and not, you know, mess each other up? So
Right.
I've kind of gotten more into like people problems, but it's something at Twitch where it wasn't like part of my role. I started working on ABR here, especially in like Brazil and emerging market countries like Brazil, India, South America in general, trying to make ABR work better in those countries. But through the course of that work, what really frustrated me was the speed at which we could ship. We wanted to iterate quickly on some experiments and changes, but what would happen is we would, take a few days to dev. We would ship it, QA, ship, roll it out. We do a tapered rollout at Twitch. So it goes to like small percentages to make sure if we break something, it's not affecting everybody at
Right.
once. Very important. And what we realized, well, a principal engineer at Twitch, Andrew Francis, he was helping us out. And he's like, okay, what's your release cadence? All right, you can ship a change every month. He's like, okay, you can do 8 experiments per year. And it's like, okay, I knew that, but you just explained that to me in a way that kind of blew my mind about how slow we were shipping software. So sometime later, I just started working more and more on this and eventually kind of carved out a little bit of a niche for myself doing performance testing, which I'm happy to tell you more about.
Yeah. Before we do that,
Yeah.
you mentioned an acronym that some of our viewers might not know what it means. What is ABR? Adaptive Bitrate.
So, yeah, adaptive bitrate algorithm. So a video player, maybe I should do like a quick spiel on a video player because I
Yeah.
think the thing that most people probably don't know about is that video players do things, and video on the web doesn't just go
Doesn't
and
just
play.
flow through and just
Yeah,
render
yeah,
flawlessly.
we're actually doing quite a few things. We use the HLS protocol, which is HTTP based streaming protocol created by Apple, and it's over TCP if that means anything to you. But what we do is we're essentially given a list of qualities in like a text file format, and we have to pick one. 1080p, 720, 480, 360. Each has like a different bit rate and size to the video segment. And what we have to do is we're trying to solve the problem of picking the highest quality that won't cause you to buffer.
Right.
So it's like an optimization problem. We want to give you the maximum amount of quality, but we also don't want your video to have a terrible experience. So
Before we go a little deeper, if you don't mind,
yeah,
um,
yeah,
for those that maybe don't understand how HLS and how live streaming works, let's just kind of talk about a playlist and what's in a playlist, if you don't mind.
yeah,
Um,
yeah, yeah,
because a lot of people in the old days, if you wanted to play a video on the web, you download the entire thing to your desktop and then it starts playing, right? Live streaming is different. How does live streaming work as far as I open the player, I get a playlist, it contains what? It contains some segments, and then what happens?
Right. Um, sorry, I was just briefly distracted by someone pinging me.
No
Do
problem.
you
All
mind
good.
winding back 10 seconds? So what I heard is in the
So,
past you just download the MP4 and that
right.
was it. Yeah,
How
there's
does
a
live
slight
streaming work?
right. We chop the video into little segments and deliver the little segments, but
Perfect.
we're doing it live. So we're constantly asking our servers, what's the latest? What's the
Yes.
latest? What's the latest? And we're stitching together this stream. And so stitching together could involve like playing 1080 and then playing 720 because your network drops a bit and then back. And that's a big advantage of HTTP streaming over just MP4s is you can adapt to changing network conditions to have the best quality of experience. So that requires code to do it. The server isn't just giving us connection like it's not push based, it's pull based. So we have to ask the server, give us this one, then that one, and mash it all together. So there's just a lot of challenges there, and it's not like there's no objective truth or correctness to it. It's an adaptation algorithm. Yeah.
Is what the IVS player does different than HLS.js? Is it different than
It
different
they accomplish the
players?
same thing. They both play video. They go about it in different ways and they have different capabilities, especially when you get into the realm of user generated content and not all content is very well put together and yes, they accomplish the same things. We all just go about it in slightly different ways. But the adaptation algorithm is kind of a differentiator for a lot of players.
How do
It's
we how do we achieve such a complicated thing in in such a limited constrained environment? I mean, this is all done on the client side, right?
yeah, again, like getting to the heart of the matter. Good question. So the algorithm for the Twitch player, it's pretty commonly used. We measure your bandwidth, and then we try to choose the quality that most closely matches that bandwidth. The Twitch player has an additional quirk. We do low latency streaming using what we call prefetch segments. So I was also author to augmentation of the HLS spec that added this, but Twitch was already doing it at the time. This was when I was working in open source. But essentially, to get lower latency on Twitch, we stream the current segment as I don't know how I'm going to say technical words, and if they're too technical,
No, oh
feel
good.
free
Oh good.
to tell me. So we use chunk transfer encoding. So
Okay.
what we essentially do is we kind of
Is
essentially
that like
create an
G
open
zipping?
not quite. We're essentially saying instead of encoding a segment, like stamping it and shipping it, and then you get the whole 2 seconds up front and you buffer that, we're doing it in tiny little pieces while it's being transcoded and ingested by our servers. So you can think if your minimum segment length is, say, 2 seconds, the server needs to see 2 seconds of video in order to make that segment, so your latency floor is 2 seconds
Right.
plus everything else happening. But Twitch latency is actually, it can be much lower. So we're just taking that last segment and we're streaming it in real time to the player using an pretty old HTTP transfer mechanism called chunk transfer encoding. But the player also needs to understand that the Apple like native players don't. So that's why on iPhones on the web, your latency is a little higher because on iOS, getting into way too many tangents here.
Oh
That's a
good.
whole nother can of worms. We actually don't control the player on your iPhone website. The app we do, the website we don't.
Is that a Safari thing or any
It's a
browser on
Safari
iOS?
thing.
Okay.
Yeah, Safari doesn't offer the API called media source extensions that we use to give raw video bytes directly to the browser. I wish I
So
had a whiteboard, like a big whiteboard to draw this right here, draw it in the air. But the video player is essentially downloading bytes and shoving them into this browser API constantly. And our goal is to just keep filling that buffer, keep filling it, make sure it never runs out.
what happens when it does run out?
you rebuffer, you get the little spinny wheel thingy. And then there's also very interesting things that happen in the Twitch player, which I think makes us a little more unique than some other players, is that when you rebuffer, we actually make the buffer a little larger next time. So the Twitch player is we're trying to discover the correct trade-off for your player. So like I said, we want you to have low latency because that's fun, it's interactive, that's part of the Twitch experience. But if you buffer a lot, that also is not good. So we're trying to discover your minimum buffer size to ensure that you never rebuffer. So if you buffer, we increase it. If you buffer again, we increase it again. So we trade off latency for buffering. And throughout the adaptation algorithm, we're always making these trade-offs. We're trading off latency for buffering, quality for buffering, time to video sometimes, where it's like, oh, maybe we'll fill more buffer up front, and it'll take longer for your video to load, but you'll have more buffer to start with and will be less likely to buffer in the future. The challenge therein is, how do you make something that works for everybody and makes everybody happy? It's very challenging.
Well, I compare it to, I've been a developer for a long time. When you're talking about this, the thing I keep thinking about is the early days, and a couple of friends and I were talking about this morning, the early days of the web when we had Internet Explorer and some of these other browsers that behaved very differently, and that's essentially what happened. Was we got jQuery because all these browsers had different quirks and considerations and things that weren't supported. So now you have this single library that kind of abstracts away some of that ugliness and gives you a single API to work with. But before that, we had to worry about the fact that Internet Explorer didn't have index of for arrays, and CSS differences between the browsers. So it's just a constant battle sometimes with fighting. You fix one thing and you break 10 other things.
Lord. Yeah, and that's a large part of what a video player does too, especially for something like IVS where we're selling the video player, is we say you can take our library and you don't have to care about what platform it lives on, whether it's on an iPhone or Firefox or whatever. You can use the same API and we'll figure out all the quirks. And when you start getting into the nuts and bolts of buffering raw video bytes, then you start hitting like, oh, the GPU on this device is bad. Or sometimes I think what happens, like I upgrade my graphics driver on my computer while a Twitch stream is playing and then it crashes. So we try to make it so that when you use the IVS player or like just any player dev in general, you're getting a consistent experience and something that's like a friendly API. And there's a lot of quirks, especially through smart TVs and all those great things.
Oh yeah, I was thinking last week, and I haven't followed up on it, but I was thinking I need to make a demo for IVS on Roku, and then I started looking at their documentation, and I'm like, I don't need to do this. Like they have like their own language.
I don't think we're on Roku.
Yeah, because I know Twitch isn't, but I mean, is there anything stopping? I don't know. Maybe there is something stopping. We could talk about this.
Use their own programming language. Bright script.
Yes, Bright script.
I just don't think we went there.
Well, the funny thing is, you go to their documentation and you look at how to get started, and one of their very first recommendations is you should hire a consultant who knows how to do this.
That always struck me as a bit odd. It's like, why not just use as a JavaScript developer, TypeScript? Right. Why not use TypeScript? TypeScript is the best.
Interesting. So, question for you. I didn't prep you with this one, but it's kind of come up in my mind as we've been talking a little bit. WIP and WEP. Do you know much about WIP and WEP? And
God, that's like WebRTC stuff, right? Yeah. That is not my domain. Yeah, I never really dipped into WebRTC. I think it would be really fun. It's just not something that needed my attention at Twitch. We have other very talented developers working on our broadcast stuff, and we don't use it for
your ladder. But
Yeah, yeah,
WebWeb
no,
and Web is the, I believe, the
yeah.
playback side of WebRTC.
y-
Apparently what people are considering to be the thing for sub-second latency, the
I think
cure.
I might be thinking of something else.
I might be
Yeah,
thinking of something else. I might be completely wrong here, and that's entirely possible. So we could
let's see.
follow up a little more uh,
Yeah. Oh,
offline.
WebRTC ingestion. Yeah, definitely. Yes, I don't know anything more about this.
Fair
I'm
enough.
just like tangential to a lot of these discussions, and I'm like, oh, that's interesting. But I haven't actually used them.
Sure, sure. Uh, so looking through your GitHub, and yeah, I did a thorough stalking of you before our chat here. Not stalking, a little research,
Yeah.
guest research. You have a lot of projects on GitHub. Some of them are a little older, but what is your favorite? Well, you already answered what your favorite front end language is, TypeScript. Do you do much back end stuff? Do you write much server side code?
Yeah.
What's your
These
preference?
days, also TypeScript. Yeah. TypeScript's great. I've used a bit of Go. So in this service that I've been working on at Twitch, it's like an end-to-end player performance testing thingy. It's really cool. We try to simulate viewership on local player builds so that we can get like performance testing before we release, which is really cool. It uses a lot of neat AWS services like Fargate, which is like the Kubernetes
Container,
Docker
yeah.
thingy. I'm not super versed in backend stuff. I'm gonna use the word thingy a lot. Um, but yeah, that we did that in TypeScript and Go, and Go is pretty nice.
Yeah.
Um, I don't know how much time we have, but I do want to plug some really cool part of the video player
Yeah,
that we
absolutely.
haven't touched on yet,
Go
which
for
is
it.
WebAssembly, and that's because I think the HTTP archive report came out recently, and it's like the Amazon IVS player. That's like the name of our JavaScript package on the web. It's the most used WASM application on the web, and we're like 35% of all WebAssembly. I don't know how they measured it. I think it's like pages it lives on or hits or something. But we're the largest WebAssembly app on the
Somehow,
internet.
somehow they estimate 35% of the requests for WASM libraries on the web
Oh,
are
okay.
for the IBS player. And I
Yes.
posted a link
Yeah.
to the article in the chat here.
So yeah, that's a cool it's a cool story. So the Twitch web player is mostly done in WebAssembly and C++ actually. And the reason for that is that during, I'm sure you were around for the Flash days. Back in the day, the Twitch player was Flash. And eventually they're like, okay, Flash is going away. You need to write your video players in JavaScript. So at the time, this is before my time also, at the time, we had this whole Flash code base. And instead of writing it in Java, in like JavaScript, we're like, okay, we want to write something that can be shared across multiple platforms,
Right.
and Player Core was born. And what we did was, I think we took the action script and ported it to C++, and then fixed it up. And then now that C++ can be compiled to Android natively, so you can use Android players instead of XO Player, iOS natively, so instead of AV Player, although it might still be. Yeah, I'm not so versed on that. I feel like someone's correcting me in Slack. It's not AV Player. Um, and then you could also compile it to WebAssembly, and that's what we did. So we
So it's a
compile C++.
shared code base.
Yeah, it's a shared code base, and that has its own set of challenge pros and cons, of course. You kind of lose some of the benefits of having a dynamic language in the web, which I miss. But it's also really nice that we can have a really consistent experience across all our platforms, which that's like always a challenge for players like JW Player or HLSJS, where they put web players in a web view on like an Android device or smart TV, and the performance is not great, in my opinion. Maybe it's better these days, but it's nice to have really like fast native code on every single platform. Um, and so, yeah, we've been using that for years. I've unfortunately have to become a little bit of a C++ dev. I'm not good at it at all. But luckily, there's plenty of JavaScript for the web team and the web squad to work on. It's like C++ core platform specific layers that do the actual integrations with those specific APIs.
Yeah, I play around with C++. Well, a slight derivative of C++. I do a lot of tinkering with Arduinos, and it's not my favorite language by any means. I mean, it's
Me neither.
it's incredibly good at what it does. You know, as
Yeah,
someone that can write really good C++ code, that's awesome. I'm glad those people exist. Um, but especially when you're playing with like very small environments with like an Arduino with very limited resources, and you have to like worry about pointers and memory allocation and all that.
it's just hard.
Yeah,
Yeah, and JavaScript is so fast, and TypeScript has really brought a lot of safety to it, and the
yeah.
tooling's good. I'm a fanboy, but I also want to correct the record from the HTTP archive. I think they said WebAssembly is likely being used as a video codec, allowing consistent video decoding independent of codec support of the user's browser. Unfortunately, that's not correct. We just the codec we don't. So a large part of the player that I didn't describe is transmuxing, where we
Right.
take MPEG-2 TS and translate to MP4, which the browser can understand. Yeah, video is kind of crazy. We deliver video that cannot be played, and then the player translates it to some. It's pretty silly, um, but and that's kind of what everybody does. It's weird, but yeah, we use C++ just for not for decoding. It's just for transmuxing and general player logic. The codec is H.264, and video players like Twitch and most other web video players never touch the codec. Um, that gets into the you can't do anything once the codec. It's like you can't take the blueberries out of the muffin. So there is like web codec, which isn't actually feel like yeah, web codec is an interesting thing, which I don't know too much about,
I mean, is that
but I think
essentially like FFmpeg on the client side kind of thing? Am I understanding that right?
I don't know too much about. It's not
Like transcoding it on
quite.
the client?
Let me see. I haven't used it. I should know this.
Oh, that's
So
all.
this is low level access to individual frames of video data. Um, I think it's. Oh, okay. It'll take too long to explain this. I don't know how much time we
No,
have
all
left.
good. Uh,
But I think web codec and web audio will be an interesting. I think that's an interesting look into the future of video players.
MC says web codecs allow you to get to the hardware. So down to the GPU level, I
That's
assume?
Mike.
Ah, okay.
Um, it
Always
allows
good
you
to
to get
see that Mike.
a coworker.
Yeah.
Um, yeah, I think it just gives you. So I think the difference is for media source, you have to give it an MP4, like a fragmented MP4 file. For web codec, you don't. You can just give it like the actual raw video bytes and
Gotcha.
audio bytes, but they're still in a codec. Like it still needs. Yeah, you're never going to deal with raw video directly because it's just too large. Everything needs to be encoded
Gotcha.
at some point.
All right. Well, we got 3 minutes over. Hopefully, I didn't. You're not up against a hard deadline here, but want to thank you
No, I
very much
no.
for joining. It's been an amazing pleasure. 20% of what you said went completely over my head, but that's awesome. That
Yeah.
I have so much to learn, and learning from amazingly brilliant people like you is one of the best part about working for Twitch. So,
Oh,
thanks.
thanks for having me. And I agree. Yeah, I've learned a lot about pretty much everything video working here. And yes, I could talk about this for hours. There's a lot to cover. We haven't even talked about autoplay policies.
Well, I'll
Which,
tell you what, John.
I'm
If
kidding.
you're interested, I would love to have you on again, and we could
Yeah.
talk longer. And uh, I'll have all kinds of amazing conversations about things like autoplay policies.
That's a joke. That was a big thing years ago, but hopefully it's okay now. But yes, I would love to come back and just blab on about video players all day.
Awesome.
You're
Right on.
giving me the perfect stage to do it. I always love doing this.
Excellent. All right.
Yeah.
Well, appreciate you again. And for everybody else, we're going to actually dig into the IVS Player SDK and start seeing how it works. So John, take care, and we'll see you next time.
Yeah, thanks a lot, Todd. See you later.
All right, let's switch the scene here. Okay, so again, thanks to John Bartos for joining. We could have talked probably the entire hour and then some about the Player SDK and all of John's amazing experience. But for now, let's actually hop in and take a look at the Player SDK. So if you remember last week, we created a new channel. And we did that a couple different ways. We used the console. We used the JavaScript SDK. And we used the Python SDK. We also looked at the TypeScript SDK, I believe. So we created a channel. And when you create a channel, we get some artifacts from that creation. We get a channel ARN. We get an ingest endpoint. We get a stream key. And we get a playback URL. So for broadcasting to a channel, what you need is that ingest endpoint and a stream key. And using the IVS player as part of our team's interview process, so good luck, Todd. Thank you. But for playback, what you need is that playback URL. So I'm going to use the AWS CLI, and I'm going to get my channel. This is a channel that I use for demo purposes. Well, we've got a problem there because my authentication credentials have expired. So we're going to use the console to get my channel information. You bear with me as I log in and make sure I'm in the right region. All right, so as I go into the console now, we can see my list of channels, and we can see here the one that I use for my demos. And if I scroll down in the details, I have a playback URL. So this is where we can get our playback URL to start using the Player SDK. And if we open up our code editor, to get started with the Player SDK, the first thing we need is a video element on the page. This is a native, if you're not familiar, a native HTML control. And we just drop this on, give it an ID, and we can get started with the Player SDK. So to use it, the first thing we need to do is include the script. And this is a CDN included script. The current version is 1.14, and we can include it just with the script tag. We can also, if we wanted to, use the NPM version and install it with NPM. There are some considerations when you do that because, as John was saying, the Player SDK does use WebAssembly. You have to kind of make some different configurations to your application, let's say, to make sure that that WebAssembly file is handled properly when you're creating your application. So you can use NPM, you can use the CDN, you could wouldn't recommend hosting your own. So I would say use NPM or use the CDN. How's it M says, and not at all a dumb question, but How's it M says, dumb question here, why would you use the command line to set this up instead of just using the Twitch UI? Or is this more if I want to add a video player to a website? So good question, and not dumb at all. So what we're talking about is Amazon Interactive Video Service, and just because you mentioned the Twitch UI, I want to be clear that we're talking about Amazon Interactive Video Service. So what Amazon Interactive Video Service, or IVS, is a service that you can use in AWS to create your own live streaming experiences similar to what you would see on the Twitch website. So you can create your own channels, you can create your own playback experiences, you can add interactivity, and you could create your own user-generated content platform, essentially. This is a way for you to build your own custom experience as opposed to using something like Twitch, which is branded as Twitch, has the features that Twitch determines they should offer to their users. This is a little different and allows you to create your own experience. So that being said, why would I use the CLI as opposed to the console? It's just a personal preference for myself. It's a little quicker and easier to use the CLI to grab that information than logging into the console, clicking and copying and pasting. I like to use the CLI just as a shortcut. If you're creating your own user-generated content platform, of course, you would probably use the SDK, because you're not going to go into your console and create a channel manually, or use the CLI to create a channel manually for every single user that signs up for your application. So hopefully that answers your question. Hopefully that explains things. So let's jump back in. So on my page here, I have a DOM content loaded listener, and we're going to start coding out the player. So the first thing I'm going to do is declare a stream URL, and I have a snippet that just pastes in that same playback URL that I just showed you. And now we can start creating our IVS player. So the first thing I'm going to do here is declare a variable that will hold the player, a reference to the player, and I will use IVS player.create. The next thing we need to do is attach the video element from the DOM to the player, and we do that with attach video element, HTML video element, and get a reference to that video player. Now we can load our stream. We do that by calling the load method, passing it the stream URL. And finally, we can call play on the player. And at this point, we have written 5 lines of JavaScript. If we save that, head over to our browser, and load our page, we can see that we have no video playing, because we're not broadcasting yet to the channel, but we do see an error in the console down here. We have a 404 failed to load playlist. So if we start streaming, we could do that. I have this little application over here with some pre-built demos, and if we, I'll just, yeah, we'll switch to that. Well, why don't we leave it to the FaceTime camera? So if I click broadcast, and I come back to the player, I give it a few seconds to buffer, we can see now that in 5 lines of code, we have a player on the page playing our live stream from our IVS channel. So what else can we do with at this point? Well, we can actually put in a listener for stream errors, and to add listeners to your IVS player, we use the add event listener method, just like you would do with any kind of DOM element. There are some special events, though, that we need to use when it comes to the player events. So the player events, there's 2 different basically enumerations or maps within the IVS player SDK, and those are the player event type map and the player state map. So we can attach listeners using these constant variables instead of hard coding the particular event name. So if we want to listen for errors, for example, we can add this listener, and we can log out our errors. So let me go back, stop my broadcast, and reload the player. And you can see that this time we actually have an error log to the console. So that error that I caught with my event listener, we have that available to us in the console. What do you do with this? Whatever you need to do. I mean, you can listen for any kind of errors. I've used this in the past as a kind of quick and dirty way to have a stream autoplay. So as we saw, when I loaded up that player the first time and there was nothing playing, we got a 404 on our stream. And then I went back to my other application and I started broadcasting, right? Well, if we didn't reload that page in the browser where the player was, the stream would never start playing until we start reloading. So as kind of a quick and dirty workaround for that, sometimes what I'll do is in my error handler, I will put a set interval in and just loop every 1 second and try to reload that stream. So just kind of a polling method to have an autoplay video and not have to tell our user or rely on our user to reload the browser page to get the video started. So it's a kind of a nice way. You could use it for whatever else you need it to in your applications. So let's take a look now at the kind of state change events that are available to us. So we have a player state.playing, and we can log that just to say playing. If we copy that down here and change that to ended and save that, start broadcasting again and reload in the browser. We can see now that we have the playing event logged out. What would you do with this? I like to use it to provide some kind of status indicator on the page that shows that the video is live. Just a little badge that I throw in the top corner of the player. And it's a nice way to, alert your players, your viewers that a stream has started to play. If we stop the broadcast over here and we come back, we should, as soon as that catches up, we should get a ended, and we do. We get an ended log to our console. So again, I can use that to change the status indicator to say that our stream is now offline. I can redirect the users to a different page. I can show them a video on demand instead. Whatever I need to do at the point in time when the player stops playing, I can do that. There is, hopefully I will not get in trouble for showing you this. I shouldn't get in trouble, of course not. But there is kind of a little cheat that you can use for this. It's not documented, so use it at your own risk, of course. But there is a player event type.state changed, and that receives a single parameter, single argument, and the current state is what it receives. So again, this is not documented, but if I start broadcasting again and I come back to the player and I refresh it, now you can see every single time that state of the player changes, we get the current state logged out to the console. So we have ready, we have buffering, we have playing. If I stop the stream again and come back, we see that we now have the ended state change object. So undocumented, use at your own risk. I didn't show this to you. You found it yourself by looking through the SDK in the console, but there it is, the state changed event listener. Let's talk about metadata. So if I add another listener, I can listen for timed metadata. We've talked about this a little bit in our past streams, but we'll talk about it again really quick here. So what is timed metadata? As I save that and I reload that. All right, we're not broadcasting. We will start broadcasting, and we'll start our player again. Okay, so I have added a text metadata queue listener to our live stream that we're using right now. What are timed metadata events? Timed metadata events are any arbitrary data that you want to send at a specific point in time in a stream that you can then use on the player side to do whatever you need to do. So for example, maybe you have a live shopping application and you want a specific product that your host is demoing to be on sale at the very moment in time that they show it on the screen. You could do that. Live sports, maybe you're live streaming a football game or a baseball game or a European football game, basketball, whatever your sport is, and you want live stats to be overlaid on your stream at the very moment in time, or as close to as possible the moment in time that a goal is scored, because obviously there's some human aspect involved here, right? You can do that. And what does that look like? If I come over here in my demo for the broadcast side of things, and I click send metadata, and we can say, hi Twitch, and hit OK. What this is going to do is it's calling a Lambda function. The Lambda function is invoking our SDK, put metadata method on the AWS SDK. And for this particular stream, it is going to broadcast that metadata. What programming languages does the... we'll get to that question in just a second here. But while I figure out why my timed metadata did not come through, let's try to broadcast that again and come back to our player. And I have done something wrong. What have I done wrong? Did I use the wrong event? If I have any coworkers in the chat here that want to chime in and have seen what I've done wrong, please feel free to do so. So we have player event type .text metadata queue. Yeah, that's correct. We have the IVS player at event listener. Text metadata queue should be logging that out. Perhaps there's something, I imagine there's something going wrong in my broadcast side of things. So instead of broadcasting that metadata from the tool that I built, let's try to broadcast that metadata from the IVS console. So we cannot do that either. Okay. So we will look at text metadata, or timed metadata, in a future stream. Sorry about that. What else is available to us? We have closed captioning support. So text queue is another option here. And if we quickly switch over to this stream, which is a test stream that we have specifically set up for closed captioning, it's a stream that contains closed captions, and we create an event listener for the text queue event, and we save that, and we come back over here. Now we have a new stream playing in the browser. This is not my live stream, but this is a test stream that contains closed captions. Okay, we've broken the entire demo. Let's try to start it over. All right then. It's kind of ironic that as soon as I started using the undocumented methods, everything started breaking on me. Well, that's okay. This is the beauty of live streams. We shall overcome this limitation. Let us try to remove that listener. And that's what I've done wrong. I used player state instead of player event type. Sorry about that. Hey, again, the beauty of live stream. Even though it was right above me in a comment, I still ignored it with my copy and paste foolishness. And now we will see there we go. So this is a closed caption. And this is just a way to, again, associate a specific piece of data, in this case, the caption data, with a point in time in a stream. So if you had a pre-recorded stream that had captions, we'd also have a demo on IVS Rocks that uses, I believe, recognition to do live captioning on a live stream, which is pretty impressive. This is how you would do that. You would be able to listen for this event and then put an overlay for that text on top of your video or next to your video or wherever whatever your needs were, you could do that. So let's switch back quickly to my live stream. Let's refresh that, and we can see that my live stream is still running. And if we try that again, publishing the timed metadata event, this time we have our timed metadata event. So opening that up, we can see here that the text at 11 seconds, with 11 seconds after starting that stream, we have a text message of this. So again, whatever your business needs are, there's a classic example that we've used for creating live trivia. So, at a certain point in time, the host announces a question and uses timed metadata to publish the various answers to the stream. So just a really handy way to create interactivity in your live streams. What else can we do with the Player SDK? We're getting close on time here, but this is one that I definitely want to show, since John had spent some time talking about these sorts of things. Let's take a look at the player quality. You would use transcribe for live captions. That may be right, Drakshad. I will check on that in just a second, and I will let you know for sure what the demo uses. So we can use, on the existing instance of the player object, we can do three things here in this particular demo. We can get the current quality, we can get the live latency, and we can get the buffer duration. So this is just really handy information to have if we want to show what our current quality is. In this case, because I'm on absolutely terrible hotel Wi-Fi, actually impressively, I am at 1080p. There's the codecs that John was talking about. My frame rate is 30, and my bit rate is a impressive, and I mean impressive, 8400 kilobits per second. Would be cool to have multi-language support, transcribes the speech, and then converts the language to whatever locale the viewer selects. We will come back to that in just a second. So, just an overview of what you can do with the SDK, right? Really easy, 5 lines of code. You can add it to your page, start streaming a live stream with IVS. You can listen for errors, you can listen for various events, player state change events, playback, ended, state change if you want to use the undocumented method. You can listen for timed metadata, you can listen for closed caption data, you can get current quality, you can get current live latency, you can get buffer duration. As you see down here, there are also listeners you can attach for the buffer update and the quality change. This is that undocumented event that we showed you above. So, IVS Player, you've learned all about it today. You've learned from John some of the amazing magic that goes into making it what it is. And from me, we've stumbled our way through a live demo coding the actual player and including it on a page. So, Drakshad says, would be cool to have multi-language support, transcribes the speech, and then converts the language to whatever locale the viewer selects. So let's jump over to our browser, and we'll go to ivs.rocks. And if we go to the examples section, you can see some amazing examples here. I can't remember how many, what do we have right now? We have 17 live demos, 41 GitHub repos, 53 blog posts, and 5 videos. So if you scroll through here, you can see some really in-depth examples of some of the various things that we talk about. Custom player controls. This is the classic trivia example that I showed, that I spoke of. Timed metadata console, a live e-shopping example. And if I keep scrolling down here, we can see right here we have an automated live captions with transcribe. So if I click on that and I open that, this example is a currently offline example. And but essentially this is an example of doing exactly what you were saying. I believe it is Drakshed. So yes, there are ways to do all kinds of amazing things. Live transcription, live captions. If you look through some of our code repos, we can, if I do a search on this page here, transcribe up. Actually, captions. Okay, here's the automated IVS, Amazon IVS automated live captions web demo. So all kinds of amazing things. And one question, how much is IVS for open source? There is, as you see in Larizon Shine's comment, there is a detail on pricing. There is a free tier. I believe it's 5 input hours a month and 100 output hours a month and a little more than that. So there is a free tier. You can also check ivs.rocks/calculator. And you can estimate here, if you were going to use this in production, here's a way to kind of break out the various costs. And depending on your needs and your output quality and the hours you're streaming, you can get an idea of how much it costs. So running late, want to thank you all for joining me. Very much appreciated. And we will see you next week right here. Oh, sorry. Don't forget the supported programming languages question. So the Player SDK, you can use it with JavaScript. You can use it with TypeScript. And essentially, I'm not sure what else you would be trying to use on the front end, unless I'm missing something. I mean, you can integrate it with any React application, Angular, Vue. There is a Python SDK. So if we're talking about the server side of things, the player is different than the server SDK. So the server SDK is for all of your kind of control, create, read, up, delete of channels, stream keys, chat rooms, all of those kind of things. And for that, there is support for C++, Python, Node, JavaScript, TypeScript, Java, all of the kind of standard languages that you would expect the AWS SDK to support on the server side as it relates to those kind of operations that you need to do, sending metadata, creating chat tokens, creating rooms, creating channels, all of those kind of operations. There is a Golang SDK as well. So yeah, 3 minutes late. Ruby, yes, Ruby is also available. Check out the AWS SDK documentation for more on that. Appreciate y'all for joining. Join me again next week, 4 p.m. Eastern. Thank you again for joining Streaming on Streaming.